Okay, thought I'd go through some of the build procedures on the MS.radicon, and you can see the videos of the actual 3D printed robot operating. I'll put some links in the description below. So let's assume you've printed all the parts. One of the first things you're going to want to do is start assembling the base unit, and all the important stuff is in the base. Here's what the part looks like coming off the printer. It's printed with no supports. This bridges across just fine. The 4 AA battery cell slips up in here. So one of the first things I normally do is slip the actual battery box in there and route the wires out here and screw in the power switch, which you can see here. The yellow ring's already around it, which is what you're seeing. It looks different. This is actually the base on the robot. And in the end, it sits like that. It screws on with 4 screws. So I bring the wires up from the battery pack, and I usually tack them, so if the battery pack gets pulled, glue them to the plastic, that the wires don't get tugged on the switch and broken or anything. And if you're using a normal slide switch which has a break before make action, which is what this switch is supposed to have, you can then use unused terminals, because an on-off switch only needs 2 terminals. But in this case, I can solder the negative to one outside and the positive to the other far outside. Gives me a place to tether the 2 wires. Then the actual power that's going to come from this, I take a servo extension cord and cut off a few inches of it, solder to the ground and solder to the center. That way when the switch is back, no power. When the switch is forward, you still have ground, and then you have your V+, which is going to feed up to the Pololu Mini 6 Maestro. The next thing I do after I mount the battery box, the switch, and solder on the short lead is the wheel drive assembly. These are continuous rotation servos. This is one here. And usually can identify them because someplace on a continuous rotation servo there'll be a small hole to get to a trim pot. In this case it's in the back end. So that the programming from robot to robot will work right, the first thing I do is I connect these servos up to a servo tester and get into the center mode, which would be your center light, and make sure that it's not rotating. If it is rotating in the center position, then you have to get in there with a small tweaker tool and adjust that trim pot until the motor stops, because center location should be stop, and anything to the left of center, should be backwards, and anything to the right of center should be forwards. So once you made sure your servos are in fact centered right from the factory, and they're not usually, you then screw them right in. They drop in 2 screws, drop in 2 screws. The wires from them come up from the back, and in the end are going to go to the Pololu controller. But the next thing I would do, and I don't have an unassembled wheel right now, but this wheel part is 3D printed, no support, and in the end you will snap a rubber grommet around it for traction. But the main thing that connects it to the servo is these servos come with a round center hub. See this piece right here? Slips into the 3D printed part and gets screwed on in 2 places, 2 screws that come through. And I just snip off the excess screw and file it kind of flat, because you don't have a lot of room on the back side for anything that might hit the servo, and you don't have a lot of room on the front side. But then once you've done that, put the wheels on, put the 2 grub screws through to tighten them onto the servos. Then the next thing that I do is I prepare the Pololu unit. Pololu, I guess. This is the Mini Maestro 6, which means it can control or input 6 devices. In this case, I have 5 channels set up as servo controllers and 1 channel set up as a digital on-off channel. And the digital on-off channel is going to be for triggering the sound effects. But before we get into that, because this device is running off penlight batteries, and because there are 5 servos in it, which can, if they're all on at once, can draw enough current that the battery voltage can temporarily drop down. If you didn't use a voltage regulator, an up-converting voltage regulator with a Pololu, then it would kind of freak out. So this little teeny guy right here, this little square guy, if he shows up, I solder onto these two pins here. That gives you ground and 5 volt into the Pololu unit, and I bring a white wire off this side. This is a voltage converter, which will take anything from just under 1 volt up over 5 volts. If it's over 5 volts, it drops it down to 5. If it's 1 volt or more, it'll boost it up to 5. So in other words, the Pololu unit then gets a good, clean, steady 5 volt supply regardless of what's going on in the battery pack and how many servos are on and off. So anyway, you take the little voltage regulator thing out, a wire to it. I bring it under and solder it on to where this main thing on the bottom side of the board, so it gets V plus straight. It doesn't go through any traces to have any current drop or anything. And then solder it right onto these two pins, and then that's your setup for the Pololu. A couple of number 2 machine screws, screw right into the top, hold it in place. This is your communication port, and actually I normally would do that next, which means I take this into the computer, boot it up. You go through a routine which you can find on the Pololu website, and then once it's recognized and everything, I feed it a program. They're actually a text file that I'd already written, put it in there, and it saves it on the chip. Next thing that's going to go on this unit is going to be the sound unit. And basically I start with these very inexpensive, I think they're made for greeting cards, and run off a couple of button cells initially. So the first thing I'll do while it's still assembled the way it comes is on my computer I'll trigger the sound that I want on there, hit the record button, record, it only holds 10 seconds, record the full 10 seconds that it'll hold. Once that's on there, I confirm it by hitting the play button, make sure it plays it back, and if it does, then I basically remove the batteries and cut the board off straight across here. I'm not going to be using their batteries anymore. And there's several modifications we have to do besides giving it a new power source. One is I need to be able to trigger it. So the only wires that I leave on the board are the 2 speaker wires. Everything else gets cut off. And the way the board's laid out, this long trace over here is ground, and this big trace here is actually a trigger pad. I think it's meant for some greeting cards when they open. A wiper can come by and hit that and trigger the sound when you open the card. This pad is very large, so I come out and I hit that with a Dremel and cut a groove in it so I can have 2 pads. One pad that's still a trigger, one pad that's basically just an isolated place where I can solder stuff. And what you're going to end up doing is basically it's a grounded emitter switch. You just take an NPN transistor, any NPN transistor, a 222 or a 3904, whatever you got laying around, and solder the emitter to the ground, solder the collector to the trigger. The base I bring up, run through a 10K resistor over to this new floating pad that we made, and that'll become our new trigger. And what that allows you to do is now, since this needed ground to trigger before, now a V plus voltage, if I supply positive to that through the 10K, will saturate the transistor switch, closes the emitter collector, triggers the sound. Very standard inverter switch configuration. And cut off a few more RC servo cables. One that comes in that brings in ground. It's going to come off the actual trigger line that's used, actually the first one. Gives me my ground for the thing. It gives me a V plus, which I then solder to part of the little battery pad that's left on here. For the moment, it just sits there, it doesn't go anywhere. And then the actual command line I bring over and solder to the resistor, which I built in my switching system there. And the reason the V plus is left hanging at this point is I want to run that V plus battery voltage up into the head. So I want the dome light to light and flash in modulation along with the sound. So I bring the V plus up there, and it's going to feed through this. In other words, I'm going to hook this LED, this is a 10 mil red LED, in series with the V plus and feed it back down, and comes back to the chip to give it its voltage. Normally in standby mode, these don't draw enough current to even be measured, but once they're actually producing sound, they draw more than enough milliamps to cause the LED to illuminate, since it's in series with the power supply. So not only does that give me my light function, but it also provides one more function. It drops the 6 volts from the battery down, you know, closer to about 4.5. And even though they were running on about 3 volts here initially, 4.5 is still fine. Works quite well. So all those mods happen, and I think this kind of shows you how I slip it up inside the part that's 3D printed, glue the speaker on top, put the module in there, and it'll have 2 cables coming out. This one cable, which is going to run up into the head, as we stated already, and the other cable, which actually in this case plugs into a control line number 1. Then the next 2 control lines are the left and right wheels that we just talked about, servo drivers. And let's see, where's that got us at now? That has us at the waist. So this piece here, here's the body part, which is a shell, which then sits on here. And this waist piece is going to, in the end, get glued on there. But before it does, a servo, similar to a normal servo. It's not a continuous rotation, just a normal, inexpensive servo. Gets screwed in here, so its center post is coming up dead center. This large hole is going to be for cables that drop down through. So once that servo's in place, it's going to mate with this upper waist part. And to do that, you just take, servos come with different horns. There will be one horn that fits exactly into this part as it's printed. And again, this is 3D printed, no supports. So I put the servo horn part down in there, and I do 2 things. One, I do super glue it, but I also run 2 screws through the horn to secure it. Once it's in place, and again, I've checked that my servo is 0 centered, so I know where center is. That way when I put this on, I know these slots here and these slots where the wires have to pass are going to line up. You drop your servo screw down through there, tighten it on, and you need a snug fit. You want just a little bit of friction. You want a little bit of drag. You don't want it sitting with a big gap and floating, because you'll get an oscillation from the weight of the mass of the body when the servo's turning. So that gets your servo parts going. And up in the upper body, I don't have one printed that I can show you, but the body is made in 2 parts, a front and a back. And it's printed with no supports also, but it does have to be hollowed out in places, which you take a Dremel to it to do that. Once you have it hollowed out, then the 2 arm servos, which if you've already prepped, would be glued to this plate. The wires will get folded back like this, and in reality this piece fits in like this inside the body. And then the 2 body halves get put back together, and this gives you your left and right arm, which come down to the Pololu unit and become left and right on there. You have to cut a small metal washer, basically, with a very small center hole, steel washer, and screw that to the end of the servos once you've glued your body halves back together and done the painting. The arms, which are printed with some support on this right here only, they're printed basically like this on your printer vertically. You glue in the magnet, and the magnet then sticks to the arm. This allows positioning of the arm. It also allows it to be removed for shipping, so it can't get broken. The body assembly, once it's made, will get glued directly to this waist part. So that as the servo turns the waist, it'll then turn the upper body, and all the cabling drops down through the slot as we already talked about. That brings us up to the head. And in the head, we already talked about this LED on top, which basically has V plus running to it, and then what we'll call the control wire running back. So you have your red center V plus, and the yellow is the control coming back, which plug into this unit. But also in this cable, you have your ground. That allows you to use two flashing LEDs for the eyes. Now, the flashing LEDs have the flashers built into them, and if you don't want the eyes randomly flashing, but you want them to always flash together, and you have, in this case, 6 volts of battery power, you can simply hook the two flashing LEDs in series, like so. That way, whichever one of the circuits turns off would turn both of them off. In other words, both eyes will always flash on and off together, which is the effect I wanted here. And they would require the ground and the V plus, which are up there. So basically on this wire harness, which runs up to the head, I bring the ground wire up to one side of one eye flashing LED. They're connected in series. The other side of the flashing eye LED needs V plus, which is already at the dome light, so I tie that in at that point. And then the dome light also has its signal return. They both come down to the audio unit. Plug into that where it gets plus, minus in the control. You've got your NPN transistor that triggers the audio unit, and all that comes back from here. And that's basically what's going on in there. I'm not sure what I've left out. All the painting, obviously. There's a boatload of hand painting. We've got, here's a couple of audio units that aren't complete yet. They have, well, this one is complete actually, so it's got your 2 leads. The little one is the one that's going to go to the Pololu unit for control and power, and the inline one here is the one that's going to run up to the head. So that shows how they are. And this one is wired for the part up to the head, but I ran out of small servo cable, so I haven't put the power supply one in yet. But basically shows how the assembly unit is made. And the arms, you've seen the round magnet gets glued in. I usually do that first because that allows me to stick it to metal clips and things. It makes it easier to paint. Initially you put this paint on the whole thing and then come back and do your others. I think we've pretty much covered the whole operation. Everything but the pain of actually doing it. It takes several days, obviously, to go through all those steps. It also takes several days to print all the parts before you can even do those steps.